L07 hypnosis. Here we have a photo or image from Pixabay, and here we have one from Flickr by Joshua Kenny. And this is a compound problem. So we have a rod and we have a disc. That's how we're going to approximate this, as a rod. We're going to do the rod and the disc. It is a rod and a disc, compound system. Let's give this radius R, capital M, and say little m, and length L. And the pivot point, the reference point, is up here. So the moment of inertia is the moment of inertia for the rod part plus the moment of inertia for the disc part. Now we already did the rod part with respect to this end of the rod, and we got 1/3 ml squared. We already did the disc. About the center, it's 1/2 mr squared, but now we got to shift it, so we can use the parallel axis theorem. We got to shift it down. This is going to be L plus R, so we're going to shift it down. So therefore, for the disc part, we'll have 1/2 mr squared, that's the center of mass result, plus m and the shift, L plus R, quantity squared. We could leave the answer in that form. That's perfectly acceptable, like that. And now the second part of the problem, we're given some parameters. Say m, little m, is big M over 4, and L is 2R. So this is like part 1, and this is now part 2. So then what you would get is, I'm gonna use this one. Let's say the instructions are give answer in terms of the big M and L, all right, and R. Yeah, let's go ahead and say this is the question. Give answer in terms of big M and R. So then we would substitute this in for M, and we would substitute in this for L. So let's do that. So we would have then 1/3 times big M over 4, and then L is 2R, and that gets squared. And then we would have 1/2 mr squared plus M. L is the 2R, so this is 2R plus R, and that gets squared. So that gives us here 1/3. That 2 squared is going to kill that 4. So that's going to be 1/3 mr squared plus 1/2 mr squared plus, over here we're going to have M times, well, let's work this out. We can work it out now, squared, or we can trifect now. Just go ahead and do it now. 4R squared plus 2 times the cross term, which should be 4R squared again, plus R squared. So 4R squared for the first term, R squared for the last term, and then 2 times the cross term is 2 times 2 is 4, R squared. So this here is 9 R squared. So I is equal to 1/3 mr squareds are everywhere. Plus 1/2 plus 9 and mr squared. You got one there, you got one there, and you got one there. So what's all this? Well, if we add the 1/3 and the 1/2, common denominator is going to be a 6 there. So this is 2 plus 3. Let's check that. 2 over 6 is the third. 3 over 6 is a half. I'm going to add those together. Then we have a 9 in there. So this is going to be 5/6 plus 9. That's kind of cool. And we're multiplying that by mr squared. So this would be common denominator here. Well, let's see. I'm going to use 6. 5 over 6. And then 6 times 9 is 54. And that's going to be 59 over 6. That's kind of cool. So I is equal to 59 over 6 mr squared. A nice result. Later in our course, we learned how to calculate the time it takes for the pendulum to swing one time, back, and forth, one cycle.